Find all rational zeros of the polynomial p of x equals x to the fifth minus 7x to the fourth plus 9x cubed plus 23x squared minus 50x plus 24. So we're going to use all of the tools we know to try to make this a little bit easier. The first thing we're going to try to do is factor the 24. So to do so, I have plus or minus, let me do a different color, my potential roots, my possible roots, possible rational zeros are going to be the factors of 24 divided by the factors of the coefficient of the leading term, which is 1 in this case. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. That's a lot. We're going to hope we can narrow it down, maybe using Descartes Rule of Signs. So for Descartes' Rule of Signs, to find the number of positive real zeros, we look for sign changes in the original. Okay, so here's a plus changing to a minus 1, 2, no sign change here, 3, and 4. So that means there are 4, or remember, if you have a sign change, you subtract down to get to 0, and you subtract by 2 each time. So 4 or 2 or 0 positive real roots. I can also do Descartes' Rule of Signs to find the number of negatives. I do p of negative x. So that means I change all of these x's to a negative. What ends up happening is that all of the powers that are odd have a sign change in front of that term. So this is negative x to the fifth minus 7x to the fourth minus 9x cubed plus 23x squared plus 50x plus 24. Looking for sign changes here. Nope. Oh, here's one. And that looks like it's it. So I do 1, and then normally you would subtract by 2 until you got 0, but I can't do that because 1 minus 2 is a negative number, so I stop here. So there will be 1 negative real root. Now remember, these are real roots. A lot of times we are trained to think about just integers, so this might be the square root of 7 plus 2 over 9. Who knows what this is. But there are 4 or 2 or 0 positive real roots, 1 negative real root, and what's the other root we haven't tested? Remember, anytime you have numbers and you classify them according to sign, we have positive numbers, we have negative numbers, and then there's 0. So is 0 a root? You plug in 0 here, you get 0 for all of these plus 24. So 0 is not a root or a 0. Okay? So let's just try one. Just going to guess. I think I'll just start with positive 1. It's always a good place to start. Remember, when you're doing synthetic division, you make sure that you have every power accounted for. 5, 4, 3, 2, 1, 0. That's okay. They're all in the right order. And I have a power for a term for every power. So I'm going to take the coefficients. I'm going to say 1, negative 7, positive 9, positive 23, negative 50, and positive 24. And then I'm going to divide by whichever these I choose. I'm going to divide by positive 1. That means the factor is x minus 1 because the 0 is 1. Okay? So remember, when you're doing synthetic division, you bring this term down. So I get 1, and then you multiply and put the answer there. So 1 times 1 is 1. Then I have negative 7 plus 1 is negative 6. And I keep going, right? 1 times negative 6, and I put it here. That's negative 6, so I have 9 minus 6 is positive 3, and so on. I'm going to stop writing the arrows. I think it's going to get really busy, but I have 1 times 3 is a 3. When I add these together, I will get 26. Then 1 times 26 goes here. That's a positive 26. I have negative 50 plus positive 26 gives me a negative 24. And then 1 times negative 24, the answer goes right here, negative 24. And if I combine 24 and negative 24, I get 0. Looks like 1 is a root. Is a 0 or a root, whatever you want to call it. They're interchangeable. So I'm going to rewrite my polynomial as a factor of these. So I know if 1 is a 0, that means x minus 1 is a factor. And then this last row here tells me what this is multiplied by. Now if I started out with x to the 5th, this is always 1 less. This is x to the 4th. These are the coefficients starting with x to the 4th and counting down. So this is x to the 4th minus 6x cubed plus 3x squared plus 26x minus 24. So far so good? Okay. And I'm just going to scroll down just a minute. You always want to check if anything has changed. Notice we still have a 24 here, so we still have all of the possible roots that we had above. If this number is less than 24, you usually can eliminate some, but not in this case. Okay, and let's go ahead and try 1 again in case it is a 0 of multiplicity. It may or may not be. So I'm going to try these again. 1, negative 6, 3, 26, and negative 24. Put my 1 back. So I bring this down and get 1, 1, negative 5, negative 5, so this is negative 2. 1 times negative 2 is negative 2. This is positive 24. And then 1 times 24 is 24. Okay, and I get another 0. What does that mean? Well, that means 1 is a 0 again. So I can write my polynomial as x minus 1 times x minus 1, or x minus 1 squared, however you want to do it. And then this is the remaining piece. It was x to the 4, so now this is x to the 3rd. X cubed minus 5x squared minus 2x plus 24. Okay? And we'll go ahead and check it one more time just to make sure 1 is not a 0 with multiplicity 3. So 1, negative 5, negative 2, and 24. We're checking 1 one more time. 1. So 1, this is negative 4, negative 4, negative 6, negative 6, and 18. Okay? And again, if I check my signs here, a lot of times I can tell if it's an upper bound or a lower bound. In this case, nothing. If it was a positive number out here, we can see if it's an upper bound, and all the numbers would have to be positive. But this is not a 0. Again, it already was twice, but not a 0 a third time. So we'll try something else. And again, look, we still have 24 at the back, so we are not able to eliminate any zeros. But if you notice, I'm going to scroll up just for a second. We had the option of 4 or 2 or 0 positive real roots. So we already at least have 2. So we may, if we have positive roots, we may have 2 more. Well, we will have 2 more, rather. It's either 2 or we'll have 2 more. Okay, so I'm going to scroll down again. Actually, wait a second. I want to have 1, negative 5, negative 2, and 24. And then remember, if you can factor this, you go ahead and do that next. We only want to do synthetic division, you know, if we can't do anything else, because it's a little more tedious just picking the 0. The process itself is not that hard. It's just sometimes we don't know which is the best 0 to choose. So if we were able to factor this, you would want to go ahead and do that. Okay, so I'm going to look at the zeros I have up here as my options. So let's try, I don't know, let's try -1 just to see what happens. I put in -1, bring this 1 down, so I get -1 times 1 is -1, this is -6. -1 times -6 is +6. -2 plus 6 is 4. -1 times 4 is 4. This is 28. That one does not work. Okay, I'm still trying to shoot for this one negative real root. So again, it doesn't have to be an integer, but I'm going to try another negative integer just to make sure. I'm going to go ahead and try -2. So I'm going to scroll down a little bit. And I'm going to start with these numbers again. 1, -5, -2, and 24. I'm going to try -2. So I bring down the first term, 1. -2 times 1 is -2. -5 plus -2 is -7. -2 times -7 is +14. -2 plus 14 is 12. -2 times 12 is -24. -24 and +24 combine to give 0. Guess what? We have another 0. So my polynomial now can be factored a little bit further. I have x minus 1 and x minus 1 from my previous tries. Now I also have -2 as a new 0. If -2 is a 0, remember that means x minus -2, which is x plus 2, is a factor. So this is x plus 2, and then I write down what remains. This will be x squared minus 7x plus 12. So we have 3 zeros, and notice 1 is a 0 of multiplicity 2. And then we have a trinomial. And remember, I told you if you can factor it, you want to do that. So let's try to factor this. If you can't factor it, you can try the quadratic formula. It doesn't really matter. So, it doesn't really matter. So if I want to factor this, it factors of 12 that that add up to 7. So x minus 1 times x minus 1 times x plus 2. This sign right here tells me signs in parentheses are the same, and I use the middle sign. And I want factors of 12 that add up to 7. So 3 and 4 minus 3, x minus 4. So my zeros are 1, -2, 3, and 4. And this guy right here, 1, is a 0 of multiplicity 2. And why does that matter? Remember, all your zeros need to add up to your highest power. So that gives us 1, 2, 3, 4, but we count this one again, 5 zeros. If we go back to the beginning, we had x to the 5th, and that's what we should have.